Welcome back. Today I'm going to be continuing to work on Kano script. So since the last video, I have done a little bit of work. So if I open this, right? So now we can actually do this properly. There is some issues, but I'll get into that. Yeah. So you like wrap this so that you know what the value is, and then you do equals 1. We might not need these actually, the parentheses. We'll see. Then it should work. So once it opens, there is still those. Yeah, you can see it works. So I can press the button and it goes, right? Before we had to do weird stuff, stuff like that. So the issue is where I'm comparing it. Yeah, the way I'm comparing it. So you can just do it like this. You might, well, I think this, right? This is going to do this one, but I'm not sure. Yeah, okay. So it doesn't like that. It doesn't like it because it's a different type. So we just you have to do it like that. I think that is acceptable. But the issue basically, it's actually in here. So compare equal, right? Right here. What we were doing before is we're taking it from the wrong one, right? We were doing a type was it a type that we're switching over, and it was a different type. What I'd like to do instead though is something a bit different, right? It's gonna be better. We're going to let me just do it. So we'll switch over the types. Let's see. So these already have that. So we'll switch over a dot type, right? And for case of int type, well, hang on, let's just do the unsigned one first. Case of u8 type. Then we're going to set the value. So we're actually going to need to make two values. So we'll make u8 64t val a val. We'll set it to 0 just for default. And we'll set a val equals a dot word dot as u8, right? And then that's gonna cast it right properly. So for if the type was actually u8, but we interpreted it as u64, it did not work properly. Sometimes it did, but sometimes it did not. Like, it's a byte thing, right? Because based on the actual bytes that are written there. We can do it like this, right? 32 and then 64. And then it's interpreted as the proper type, and it actually gets casted in the correct way. We can do this for each one, right? So we'll use the a value as what we're comparing, and then this will get the actual proper type. So if we do that, and let's see. And then we have the a val, right? So then we can, once we get the b val as well, we can do a val. Like the result will be a val equals b val, right? And that's going to make it way nicer. And we can probably use a macro for this as well to expand, right? To get the actual proper type. So basically, we can probably get rid of this entirely because we don't need this compare as type anymore. That macro, we don't really need it. I'll leave it, I guess, to look at the types. But if we do that, and then we do the same thing for the b type. So I'll make a macro for this again, a better macro. B dot type and b val. B. Right, and then we need b val. So again, this is only going to work with unsigned integers now. And we can probably do it with the regular int as well. As long as it's greater than 0. So that might, well, let's see. Do we want to be able to compare those? We probably do. So I'll just, yeah, I'll do that. And then I'll figure that out later. Dot as, that's what this is called. And we'll add the same thing here. As int, b. Okay, b val. And then we can just compare them, right? So what we have to do to figure out this type is we had to switch over the types. So if it is any of the U8s, or of the unsigned ones, then we'll do it like this. So yeah, basically do another switch segment, so it's gonna be nested ones, but that's fine. A dot type, switch over that, and this will be case of U8, case of U15, case of U 32 and then U64 as well. And yeah, then we have this, so I'm going to get it one more time. And in case of a regular integer, yeah, I guess we kind of do it the same. It's just these values are different. So maybe, maybe. Well, let me see. So case of type, and it's supposed to be a type, not. Oops. Okay, okay. Then we have all that, and then we'll have the int type, which is gonna be similar because we can still use the unsigned ones, obviously, to compare with the integer. So, but basically this can be different. So this will be a signed integer, right, like that, and then the rest can be the same. So this, right, so this could be a macro in itself. And well, I don't know that I want macros calling macros, so I might be able to just condense this part into a macro, right? Do we want to do the floats as well? I guess we could even handle those, couldn't we? We could handle all the data types in here, and it would just cast them, right? Okay, I might actually do that. Let me try. And then we can do a similar thing for all of them, right? Right. Okay, so let's try. Anyway, so we have int type, and we have float type. As float, and then we have whoops. We have double type dot as double, and then char type, which already char type should have been included. That makes sense. It's basically just an integer, right? And then we have pointer type. And that should be pretty much it. So we add these to here. Anyway, it's just going to cast them to whatever is acceptable in that way. And I think that is acceptable. It's acceptable. We can change the A. Oops. Okay. And yeah, kind of have to do this here, but if I make a macro for it, then we wouldn't really have to do that. In the case of float or double, I guess I might just compare it as a double. I'm not sure. Let's see. So what do I want to make a macro for? I could make a macro for the whole outer thing, but I don't know if that's necessarily going to be super helpful, right? I think I'd rather just do it for this part, right? Because then if we switch over every type, then it'll work. So let me copy this and make a macro. So we need that. And that's pretty much, yeah, we just basically need to switch over the types. So I'll define it in here, and then I will, well, actually, I guess this is a header file, so I can define it wherever. Put it here. So we'll do fine, and this will be compare, okay. Compare as type. Okay, yeah, so I had that. We don't really need that anymore. Not really compare, but get type, right? Get type. And there's a few things I will need to pass, so we'll figure that out as we go, right? I need to delete some of these. Okay, we'll do a slash here, and then all of these need a slash. There's some extra space there as well. A lot of them. Let me get rid of some of those. I don't really care if they are all necessarily formatted properly, but that's fine. Yeah, and that is not a. There we go. That should be it. Okay. So this, we'll switch over it. Don't think we need the do wall. Don't know that we need that. Because we don't really define anything already. And we have this switch, so that should be fine. So we'll switch over, yeah, we can use actually just the, var, right? Var. So switch over var dot type. And then var val. So we'll need to pass those. Maybe we'll just have var val. So this can be val. This is the val that we'll set in here. Okay. And then this is the var. So var. And this is pretty much it, I think. So then we can just call this. Okay, hopefully that does work. So get type. Yeah, and we have that. So we'll switch. Let's go down to that. Okay. So we have this. So basically we can just do get type. We need b and b val, right? And that's all we have to pass. It should be. And actually, I guess we can't really do the semicolon there. So let me actually let me check that. Let me see. Do I want a do wall? I think that actually might make sense. Let's just do that regardless. So we'll do do. 0. Okay, and that should work. So there we go. Okay, so get type B and that, and then also the A1, and that basically converts that all into that. That handles all of that. And B, there we go. There it is. So there's not very much. It's still like this, but that should be fine. We might be able to make one where we pass type as well, but this isn't too much to do anyway. So then we can get rid of this as well. You know what? We could do this even, we just set the values. Okay. We can't really define it outside of here, because we're defining a new variable. And yeah, we don't know what the type is necessarily. So yeah, we're gonna have to define it like this. Right, and we don't know what the values are, so yeah, we're gonna have to push onto the stack as well. Okay. So there's a bit of stuff that we have to do still, but that's int type, and then we'll have a float type. This will be float and float. And then double type, and we need break statements actually. I forgot about that. Break. So yeah, maybe a macro would be good for this to switch over all the types, since it's gonna be the same thing always. Or we can even return well, I don't know what return necessarily. Well, let's see. So yeah, I might want to do that. It's just, when you have macros calling macros, it might get confusing, but I can try it. So this will be double type though. Once I make sure it works, it's double. And yeah, these are still the same. So eval like eval. Yeah, I guess we don't really need to set the values, do we? Not really necessary. Okay, so we have that, in 64, float, double, and that should be pretty much it, right? So the thing with the float and double, there might be some issues, so I might want to combine them together, and I might not, I'm not sure exactly. But floating point values can get confusing. And then we'll have, well, I guess we could do the same thing for the character type, right? Case char type, and then probably pointer type as well. Right, because the pointer, don't do case uppercase. Case, right, the pointer at least, it's always gonna be positive, right? So I think that makes sense to do like that. So that should be fine. So that should pretty much cover all of them. Then we need just one of these, and then we can get rid of this. And hopefully it does work. So I'm gonna test it and make sure it does work. And then there is the default case, which I don't think we need that. So probably, well, do we want that still? We don't want the break yet, actually. So this can go right here. Break, and then we want to push the value, right? Which I think I deleted doing that, but we can grab it from down here. Do we not push the value? Oh, when we do compare his type, it pushes it. Okay. So basically just need to compare them, yeah, and then push them. So I have to do it in each individual one, actually. So so we get the type of each one, and then we can just gen push, and then not gen push, just push. Okay, push machine, and we want the value. So we need a word, right? And we can pass dot data, not value, dot equals. Well, it can be as UA, because that makes sense to return equals this, and we wrap it, just make sure, and then dot type equals type U8, right? So that'll basically be the Boolean type, and we have to add this to each one because again the issue with the stuff. So we'll do that. Okay, and because these are not visible outside the scope, so let me see if that even combines. Almost. Okay, get type. It doesn't like that. Okay, I think I forgot some break statements, so let's do that. Break. I should use a formatter. I was saying it before, but I think a formatter would be helpful. It'd probably make the code look a lot nicer as well. Okay. Okay, and let's try that now. Register type is not handled. Okay, and then default, we will assert unknown type or incorrect type, something like that. Regardless. Okay, do that. And alright, so that is it. Okay, because you don't handle them all here. Yeah, we'll end the default here. And then assert false unknown type, right? I should probably improve the error messages at some point, but you know, and maybe even an assert is not good there because it should just be like print error. But B valve set but not used. A valve. Okay, did I? Oh yeah, A valve and B valve. Okay, I messed that up. My bad. Copy it again. Okay. Okay again. And there we go. Okay, two few elements to push. So push machine. Oh yeah, okay. So you don't put the type like that. You just pass the type. This type. You don't have to type, and you do type right. Okay. And that's gonna be for every single one of them actually. So okay, okay. Okay. So it isn't like that. Is it 2-8 type? Is that? Yeah, it is. Okay. Yeah. Just made some silly mistakes, and then they're gonna change everything. It's not great. Not great. And also, there's a lot of tabs now at the end, so I need to fix that. No member name val. Okay. Is that what it is? No. Let me look at so weird. Alright, we just have to do dot as in because it is not one of those. So it's just dot as in. Okay. This isn't too bad to change. Yeah, because it's just it's a union. Okay. Okay, and it doesn't like that. Valid. What's that? What is wrong here? I don't get it. Hang on. Incompatible types when assigning type double from type void. Alright, so it thinks it's a void pointer for some reason. It should be visible in the scope, so that is not the issue. Let me look at the get type again. Get type. So val. Ooh, okay, want to set. Well, no, hang on. Val. Yeah, val is right. And then this is supposed to be a dot word. No, because it's we do dot word, so that's not it. Dot word dot isn't. So why is it void? I don't understand that. Right, so it recognizes this, but it does not like that. I could do this, like this, something with that. What happens? No, okay. It says the same thing though. Oh shoot, oh shoot, when it's a pointer type, we can't assign to that. Because it's a void pointer, so we need to actually cast it. Alright, so that's actually what the issue is, I think. This one needs to be casted. Yeah, so we can put these back, because I would like to have those anyway. But I didn't know if they were interference, so that's why I got rid of them. But yeah, we can just cast this, I think. Cast it, we'll just cast it to a U in 6 T, right? And I think that will be good, right? There we go. Okay, so it does do that. Let me see if it works. Okay, it looks like it does actually work. So let me go here. And what if I change side? So 1 equals is down, right. And yeah, that stay, okay? The key right is actually all capitals. So. And there's something as well. Okay, let's go there. Save that. Right, so it should work on either side, right? Okay, there we go. And yeah, so now it actually works properly. The other comparisons are also working here. Let me actually try real window, and that should hopefully, and it does not work. Okay. Expected type int, but trying to type pointer. So on 79. Oh, okay, so it doesn't let us assign to that. Data. What is data? Okay, well, let's make it a pointer instead. Yeah, if you can't reassign those like that, I think that should stay. Fields like okay. Alright, and yeah, so it's the type system getting in the way, right? This is why tests would be nice to automatically rebuild these, because then I would know. So it doesn't like that. Pointer and int. Okay, so we need to like do why is it a pointer? Oh, okay, because this is a pointer type. I see. We need to cast them basically. Yeah, that's where casts would be useful. Right. Okay. I'm going to come back to this, right? 30. No, 8. Data size. And 0. Right, so it works with that because it recognizes it as an int. But yeah, both of those issues need to be fixed, right? It's just type system. Alright, great. What if I do loop over it, right? So I equals 0, and then I is greater than I is less than data size. Yeah. Okay. And we'll do data I equals y. Okay. And it gets stuck. Okay. Oh, we need to do I equals I plus 1. Okay, that almost worked. Almost worked. Okay, there's a few issues with that. I'll come back to that. I'll come back to that. Okay. But that comparison does work. So now, do I want to make a wrapper macro for this, right? Because, well, okay, I can't really. Well, unless we just pass the operator here. Operator and then the type. The return type. Return type and operator. Well, okay. Yeah, I think we should do that probably. So this can just be, well, hang on, let me look at what we have here. We have like compare as type. Let's just do, right there. We'll call it, say, compare. Not compare, but rather, type operator. Okay, something like that, right? We pass the operator in there. And then, well, maybe the type first. So this will be U8, the return type. U8, and then, okay, but it needs to know the type here as well. So, all right, so we can have that, and then U8 type. We could even maybe create a word to return. Something like that. Well, okay, yeah, what if we do that? So well, not a word, but a data. This can be the return equals result equals so dot word as int. Okay, no, we need a word in here. We can set the dot type equals U8, and we can set the value of it in here, right? Okay, we could do that. So then we just pass the result here. And then also the type, right? So we need both of them, right? Okay, type result, and that's what we'll return here. So we'll do like, well, okay, that's not even really any better. I'll just get this. U8 type. Yeah, okay. And then we need the operators, equally for this case. And then this will do just basically all of this. Okay. It might be useful to actually open this in Jam to do this. Because I'll be able to do it a bit faster, right? So we have all of this. Yeah, so this is like op, right? Something like that. That might not be a very good name, but you know. Okay, do we want this still? Well, this, well, hang on. So we call that. It's always going to be A and B, so I think that's fine. Yeah, okay, that'll be fine. We'll just, hopefully it's fine. I might have to come back and change it, but that's fine. So we need the, this is the, let's see, the type, but it's really the, data type, and then need the operator, right? Something like that, like this, and we'll do, well, no, we'll do that. Do this. And then let me actually, let me finish it, and then I will do that, and let me add the while 0. Okay, and what I want to do here, I should get rid of that. Okay, so what I should do here is, what the heck, why is there a big, oh shoot, it's because of all the extra tabs that were there. Yeah, get rid of those. So you can just, and delete to there. Yeah, because Kano kind of ends up inserting a lot of extra tabs sometimes. This will be as data, and this is operator. Can you do operators like that? I don't know that that will actually work, so I'm gonna have to do this. Oops. And here as well. We'll see if that even works. And this is type. Right. So basically that's what we've got. They're all the same, so. Okay. Let's see if that will work. So let me insert actually. And line insert one of those. And there we go. Just fell out right now. And let me see if that compiles. Well, okay. Let's go down to repeat and get rid of these. What the heck? And let's go back here. Okay. And now there is some issues with that. Is it back? No. Alright, so I do miss something up. Let's see. I'm missing something. Okay, so that does not close properly. So I opened something and did not close it. Because that closed the switch thing. Okay, so I need to bring this. There we go. And I need this as well. Dang, okay. When I do this, it's something like that, to insert it properly. Right, because this sort of sees it as one thing, right? Okay, AFL set but not used. Why does it say that? Yeah, I don't think that works. So maybe, maybe, if I just pass the whole thing here. Can't do that though. And let me look. I have one up here where I use it, so as type. Okay, yes, we do have an as type like that. So let's actually call it that, so it's like consistency, right? So I'm not super proficient in macros. So we'll call it that instead. As type. Okay. Yes, we need to change that type. As grid. Double to type void pointer. Okay. I thought I casted it. Data has no member named U8 type. What? Switch A dot type. Why does it not? It does though. Name U8 type. Why not? We have U8 type. We do though. What? What the heck? Is there something I'm missing? It's this one, though, not up here. Right here. We have A and B. Huh. I don't follow. U8 type. And it is right here, U8 type, and that works. So, what? It's something to do with expanding the macro in another macro. And let me there. Go here, because I have this, which calls assert, and it just works, you know? It's not a problem. So that's not the issue. Why does it not recognize U8 type? What if I get rid of that? Okay. Huh? Data has no member. Oh, shoot, I see. Okay. This is the return type. Okay. Yeah. I can't actually replace that because you have other places. So, type. Yeah, it was filling it in for that, and that makes sense. Turn type. Okay. And now it does compile. It just works. There we go. Okay, it does still work. So now I can use it for all the rest of them. So, so we can use that here. We can just do that. Type not equal. Get rid of all of this. And there we go. You can see it's way easier. So compare greater, same thing. This wasn't even handled fully. This is grading. And they are just copy that. Less. Oops. Okay, and this is greater equal. We have less than equal. We can use this for the plus and minus as well. Okay, got that, and let's go up to, right, so these, we don't need them anymore, because they are not used. Right, okay, yeah, so this is just basically what I can do here now. So we need to pop them off. Basically need just this whole same thing here that we have right here. Let's go to add. Do that. We should check the values as well. And U8 type. Okay, the return type is gonna be, oh shoot, but the return type depends on what the type is. So I guess we can switch over it initially. Switch over a.type. So if it is these, then yeah, the return type, well, okay. Yeah, we kind of need to call it a few times, which isn't great. Shoot, I didn't think about that. Let's see, we have a bunch of different types here. So we have pointer type. Int type will be different. It's U64 type. And we'll do this. Okay. 64. U64 type and plus. Int type is just going to be as int. Alright, float type, oops. Float type. Okay, and then double. Right, so these, they can return that. I think that's probably fine. Oops. Double type. Okay. And then we need, you know, all the other unsigned types. We need break statements as well. I forgot about that. We have breaks here. Okay, back up. Break. Break. Okay, this will be U8. That's 8 type. And then 16 and 32. And actually, I think the chart type should be part of U8. If that makes sense. Maybe. U16, 32, 32, 32, 16. Okay, and that should pretty much cover that. Get rid of this. This should handle all the stuff that we need to handle there. And we don't need this anymore. And then, yeah, we can just use this for the rest of them. It's basically the exact same thing. Let's go back here. Yes and no. Okay. Yeah, I can get rid of them. Let's see. So this, it does work. Okay, and the addition still seems to work and all that stuff. So I think I'll add this for all of them, and then we can push this, and that'll probably be about the end of the video. But yeah, now it's much more powerful, right? Because the types actually can interact properly. Sub, right? Sub, and we just basically need to replace plus with minus, and that's it. So maybe can you make a function for this? Well, okay, but we can't really pass the type. I don't know. Okay, let me think. So if we had a function, right? We had a greater function, and we pass like an enum for the type, then we can switch over to enum and put this, right? And then that could probably work, right? Because the rest of it is all the same. So I might do that. That might be a good idea. Good idea indeed. But I won't do it for now. For now, it's fine if there's a bit of repetition, right? Multiply, same thing. Multiply, there we go. And then divide and mod. Alright, so we do need to check actually here as well that it is not 0. So we'll grab this. Right, so we have 2 ways to error it. Kind of cuts off a little, but that's fine. And then, yeah, replace multiply with divide. And we need to do the same thing, actually, for the next one as well. Divide with divide. There we go. Let's grab this whole thing and place it here. Yeah, so there's not a lot of boundary checks, I suppose, here, so that's kind of a problem. Place divide with mod. Okay. Get rid of these. And let's see, that should compile. Got to do this. Okay, now there's some issues. So you cannot mod those types. Okay, so the mod type is not going to work unless it's integers. Okay, I didn't think about that. So this could probably go back to how it was then. Right, mod, yeah, okay. So it's called math op. And what did I pass? It was as in mod, like, something like that. It's fine if the mod's not super powerful or whatever. So get rid of all of this. Still need those checks, so that's probably helpful. And get rid of this. Okay, that should cover it, right? Okay. So it doesn't like that. It's int type, right? Okay, and then if you get rid of a yes variable, yes and no. They were kind of stupid anyway. It's like, it's because I'm a bit of a novice. Anyway, now this does not work. Okay. Oh, it's because I closed it. And yeah, I need to get rid of this if there's an error or something, because otherwise it doesn't compile properly. Index out of range. Perfect, perfect, perfect. What the heck? Index. It's out of in the swap? That's not good. Oh shoot, I know why. I know why. Because I'm doing this, but I don't want to do that. I want to, well, okay. We're pushing the values back on. Do we still want to get rid of them though? Let me think. Not sure we do. Or we push one value back on, but that should increase it anyway. Hang on. Let me look at how the math op worked before. We popped them off. Yes, we popped them all off. So, which isn't great, right? So that should be the same as this. So I don't know why it would do that. Unless, for one of them, I did it too many times. Stack underflow? Yeah, these are all stack underflow. So it was in the swap. It's messed up. Why? Let me change it to 1. It shouldn't be really doing it. I don't think we use the other one, so. Excited range, interesting. What if we don't subtract anything? Which, I think it still should, but. Interesting. Okay, so maybe it's not with it. Right, so it was working when we were doing it just here, but then we had the rest of them, it does not work. So, right, let me go back here, source, and go to tim.h, and take a look at that quickly. So sub. Let's go here. Yeah, so maybe I just put it back as that. Right. Okay, and then I do it how it was before. So now. Now I have to delete the file again. So it's something with this one is not right. This equals 2. Minus. We don't pop anything off here, so it shouldn't be that. Shouldn't be something to do with that. Do not break? No. It's not what it is. This really needs to be greater than 1 there, but okay, that is concerning, right? Concerning. And we push it on. And get an error if any of them are correct, so that's not it. So it is pushing. That's interesting. But only with sub. Okay, am I doing sub wrong? Right, let me think. It should be. Right. Let me try GD. I can see like where that is being called from. Let me do that. No. Okay, let me run, break on run instructions. And then run. Maybe I shouldn't do it in that mode. So let me break on run instructions. Run anything. Yes. We'll take a look. Okay. Run instructions. Switch over it. I think now we can enable them. Right, so these are just loading all of the functions and stuff, so we don't need to really worry about that. Push stir, so this is another one. Another one. Okay. Stir. Okay. Okay. That might be the last one. So we did that one. And there is one. Okay. Load it, and then is there another? Is this? Yeah. Okay. So there's one. Okay. This is probably the last one. It's gotta be. Is it? Clear background. I think so. I don't remember though. Okay. Then push stir, but this could be a different still. No. Okay. How many are there? What the heck? We load a lot, I guess. Okay. There's a lot. How many are there? Who's the last one? Set target FPS. Okay, so that's the last one. Draw rectangle. Okay, so it is not the last one. Is the next one? Wait, what is it? Draw a rectangle. No, okay, so there's still a bunch more. Alright, let's keep going. That is get key press. So the next one I think is the final. Yes, okay. That and push. So we are pushing that. Instruction data ID. Int type and it's 1. Okay. Let's see, I don't remember what that is necessarily. So 1, it's probably setting up this thing. Let's see, so once we get to like a dupe or something like that is when we're gonna have the issue, right? So we're doing all that. Right, that was a dupe, but it was not the issue. Not the problematic one. Alright, so add. It's alright, where do we sub actually? Do we do sub at all actually? Hang on. But we do call it let me change stuff. So maybe I'm actually doing that in the wrong order. Ooh, I didn't think about that. Is that what it is? We're subtracting from the wrong one. That's gotta be what it is, yes. Okay. Change this to be an A. There we go. Okay, that's what it was. Yeah, so I'll probably switch it for all of these then. Like for the well, multiplication and addition, they don't matter. Okay. For consistency, right? Okay, and then it works. Then it works. And we can move down. So we should be able to easily expand it. Okay. So one. We don't need to do it like that. We can do that equals that. Looks kind of weird like that. One. So key left. Let's try that. Make sure it works. Nope. Why not? Oh, because it's not set to proper type. That's why. There we go. We can go back and forth, and we can move up and down as well. Down and key up. Y, Y. And that should be the right order, hopefully. Okay, and there we go. We can move all around, and we can change the speed. Maybe we'll use what's speed. And this is a bit more lenient in the values of things. So we can do something like speed. U32 I think makes sense. 200, and then yeah, 200. 200 is gonna be too high. Let's do 10. There we go. And nope. What the heck? Oh, U32. Click on this. We should be using that, so I'm not sure. What? Expected type 0. So expected an int. Which one did? Oh, shoot, it's probably one of these. Okay. Rec X and rec Y. Yeah, all these can be U32, all the ints that you see. Well, that might be like a U64. Well, no, these 32 is. I think that's what the issue is from. Right, because then that actually changed the type when we had the speed was that type, so it was an improper type. But let's see, there's some more where it doesn't have it. Okay, because this is not the correct type now. But we can do that later. So fix. Right, so I do need to fix this. As well. Damn, I type 3 to find a 0. Oh, for this one. This one again. So we can make that color as well. Right, just random numbers, right? But yeah, so this is, yeah, that is an issue. So we can't really pass them in that proper way, which is not great. But that should fix it. There we go. Okay, and then we can move all around. All that stuff. So basically, what happened before was it was expecting an int here, but this got casted from an integer to a U32, and it caused those issues. So that is why. But yeah, we can do this now. We can move all around. So Raylib, written in KanoScript, calling Raylib. There's some issues with the types, right? Comparing them and things like that. But otherwise, it does work pretty good indeed. All right. So that I will commit that. Push that. Okay, so hope that works. That is going to be about it. So thank you guys for watching, and I'll see you guys next time. Bye.